Welcome to another video on Blue Tech Empire Python tutorials. In this video, we are going to be looking at Python's basic operators, and here particularly, we are going to be talking about the identity operator. You may not use the identity operator quite often in your day-to-day programming operations, but identity operator is very useful sometimes when you're dealing with objects of a class. You can use it to know if two object references point to the same class or if two variables point to the same object. So it's very important for sometimes for you to notice that. And we are going to be looking at, particularly, we are going to be looking at how the identity operator works with Python basic data types like the integers, floats, and lists, tuples, and the rest. And later on, we are going to now look into how you can use it for a class declaration. So in a few moments, you're going to be seeing all that. So let's get directly into the video. Identity operators aren't that many. um you know we have just two, like we saw with the membership operator. So we aren't going to be looking at a lot of stuff here in this video, so it's not going to be very long. We have just the is. I'm going to read from here. Identity operators compare the memory locations of two objects. There are two identity operators as explained below. We have is evaluates to true if a variable on either side of the operator points to the same object, and false otherwise. It's not evaluates to false if the variable on either side of the operators point to the same object, and true otherwise. So let's look at one of the most basic stuff. For example, let's say let's exit this Python. Let's clear, and we have Python now. Python getting. All right. So let's say, for example, 2 is 2. Is it true? Oh, yeah. 2 is 2. Um, True. It returns true, but they asked us a question. They said syntax warning is with the literal. Did you mean is? We normally supposed to use 2 equal to 2. Yeah, normally. But even though it returned true, but you don't ask if a literal is another literal. You see, the one that told us here we're using literals. Normally, we do it with variables pointing to the same object. For example, if you say a is equals to 2, sorry, a equal to 2 and b equal to 2. You can now say a is b. It gives true. Now you may be wondering, are we saying, is it user is not, just want you to understand, this is not the is not comparing the equivalence of the value. Rather, it is comparing the equivalence of the memory location. Now I'm going to be explaining that to you. Now, if you haven't watched the video where I spoke about immutability, mutability, and the garbage collector, it's very important for you to watch that video to understand how Python stores values in memory. It's very important because from there you're going to know when we say an object is immutable and when we say it's mutable. Now, when you create an object in memory, for example, var1 equal to 10, what Python does is it actually creates an object in memory. It detects the type of this variable. As you can see, this is an int. So Python creates an int object in memory. It saves the value 10 in that object, and it takes our variable name and points to that memory location containing the value 10. Our variable name in this case acts as a tag to that memory location. Why? Memory locations in the computer are very complicated. You can't cram them because they're quite long, especially for those dealing in those days. You could use direct memory locations, like if you were programming in assembly language or machine language, as computer RAM was so small. In those days they had 16 megabytes RAM. Not now we have 32 gigabytes, massive RAM. They had kilobytes RAM. So computers were still very small and computer memory wasn't that large, so you could track all locations in your code. But now, where we have large RAMs and stuffs, you can't actually memorize the memory location. So modern or high-level programming language came up with the form of what we call a variable name. Here, for example, var1 is a variable name. Var1 is actually points to the memory location containing this object, integer object 10. How? If you want to check the memory location of var1, you simply type id var1. Remember, id is a built-in method provided by Python, so it's always available. You just type id and you pass the variable name. You see, var1 is in the memory location 1 for something, I guess somewhere around the third or fourth gigabyte of my computer, or let me say the third gigabyte of my computer. If you take this, let's find this in gigabytes. We are going to know this space in gigabytes. It's very easy to calculate it in gigabytes. All you need to do is um, just take this value, divide it by, take this value, divide it by 1 megabyte is 1024 bytes. So divided by 1024 times 1024, you're now in megabytes. um, times 1024. So 1024 gives us 1 megabyte times 1 kilobyte. 1024 bytes is 1 kilobyte times 1024, it gives us 1 megabyte times 1024, it gives us 1 gigabyte. So if we divide this by um let's say divide that by 1024 times 3. Let's see, we don't have, I'm going to get to scientific. Yes, let's divide this. Let's divide this. Divide by 1024 times 1000 and sorry 1024 times 1024. When we close this, now it's equal to, all right, we already have it. All right, so as you can see, it gives us 131. It gives us 131. So we can say, if we check the 131, we can extract this 131,000. We can divide it again by 1024 divided by, so we get an approximate number. Now, you can use that number, you can use this calculation to know the exact location in memory, even though it's not really the exact location in memory, because normally our programs don't use direct memories. We have some sort of an artificial memory our program sees, or a visual memory our program sees when accessing. But we can't talk about all that here. But just know this memory location is actually where this value 10 is stored. So here is the actual memory location, but since we can't cram this, we use var1 to point to that memory location. So each time you use a variable name in your code again, know that variable name is pointing to a particular memory location on your computer. So for example, let's continue our what we have. We're writing var1 equals to 40, var2 equals to 35, var3 equal to 40, var4 equal to let's say 34, and var2 again equal to 33. Let's say 35. Now, in all these steps, something happened. Now let's do it again. After every time we type id var1, let's do it again. So I just want you to really understand this. So let's say var1 equals to 40, id var1, var2 equal to 35, id var2. We are checking the memory address of those positions. var3 equals to 34. Oh, sorry, var4. Let's say var3 var3 equals to 40, id var3, var4 equals to 34, id var4. And let's say now var1 equal to 40. Var1 equals to, let's say, let's change var2 instead. Let's say var2 equal to 35, or let's say var2 equals to let's say var2 equals to 36, 43. All right, let's say that id var2. It's very important for you to understand this if you want to understand how the is operator works. Now let's start. Var1 equals to 40. What happens is the computer actually detects this an integer, it saves it in memory, and it points our variable name var1 to that location in memory. Okay, we said var id var1, so here is the location in memory where 40 is saved. All right, we went to var2, it recognized this as an integer, save it in memory, point var2 there. Now we have the memory address. Notice it's different from this. Now we have var4 equals to 34. What Python does, or let's say var3 equals to 40, what Python does is it already has 40 in memory. Remember, like we have explained this in our video on variable types and also immutability and the garbage collector. Now, so if you want to understand it properly, you can go to that video and just like doing a rundown of what we did. So in this case, where we try to assign var3 to 40, Python already has 40 in memory because it created it when we assigned var1 to 40. So Python just takes var3 and point to that memory location. So if you print var3, the ID of var3, you see it has the same memory location as this. So you see Python did not create a new object. Now we went to var4 equals to 34. Python does not have 34, it creates a new object. Now, we went back to var2 and changed its location to 43. Python var2 initially pointed to 35. What Python does is Python cuts that bond from of var2 linked to that memory location and instead points it to a new object it's going to create now, 43. Now var2 will point to 43. This 35 is going to be have a reference count of 0 like we explained in the video I'm talking about, and later on it will be garbage collected. Now, as you can see, var1 and var3 have the same memory location. So if you write var1 is var3, it's going to give you true. Now, here is the simplicity. If we have a equals to 10, b equals to 20, c equals to 10, and d equals to 20. Now, if you write id, let's put id a, comma, id b, comma, id c, comma, id d. Now take note of these memory locations. That's actually a way of printing a tuple, so you should know why it's in in brackets, because we printed this as a tuple. So now take note, id1, there is it. id2, it has a different memory location, but take note, id c and id of a have the same memory location. It means when Python created an object 10 and reached this line, it did not create an object 10 again. What it did was it just assigned C to the old object you already created. And when we initialized B with 20, Python created an object 20. Now, when we came later on and said D equals to 20, what Python did is just pointed D to that old 20. So you see, C and D have the same memory location. Therefore, because A and C point to the same memory location, A is C will return true. Why? Because A and C point to the same memory location. But as you can see, A and B point to the different addresses. They don't point to the same object in memory. So if you say A is B, it's going to return false. Now, B and D point to the, as you can see, they have the same value for their address, which means they point to the same object in memory, they point to the same address. So B and is D should give us true, but B and maybe C, or C and D, or what, even A and D point to different locations. So if you write A is D, it's going to return false. So I just wanted to see how the is works. It works only if those objects point to the same address in memory. Now let's try something. Let's see if it works the same for integers, or let's say floats. A equals to 45.50, b equals to 45.500. Let's see id a, id b. All right, you see these are different values, so I don't want you to make this mistake. The fact is 0.00 doesn't mean it's the same value. I think so what happens here is only for exact values. It's only when we have same values that will cause Python to like point to the same memory. I don't know whether that makes sense, but if A points to a value and B is that same value is assigned to B, that's when Python is going to use the old memory. As you can see, these two values are not the same. So if we wrote A equal to 45.50, B equals to 45 45.50. Oh, sorry, let me do it this way. A equals 45.50, B equals 45.50. All right, now we can now say is A is, let's first see ID of A and ID of B. ID A, comma ID B. Well, are they the same? A ID B 45.50, 45. All right, let's use different variables to be sure. var1 equals to 45.50, var2 equals to 45.50, id var1, id. All right, so as you can see clearly, let's see 439, 439, let's see 432. Oh, we have some mistakes because Python is actually using the old memory location. Like you can see, Python even used this memory location. Python used this one, this old one. So Python keeps using its old memory location, and you can see. But so the best thing we can do is actually to create everything from. Let's use a different value. Let's say var1 equals to maybe 100.550, and var2 equals to 100.50. Let's see id var1, id var2. All right, so as you can clearly see, Python wouldn't assign these floats to the same memory location. I don't know why Python decided to do that, but as you can see clearly, id of var1 is not equal to id of var2. But if they were integers, if we had, let's say, var3 is equals to 400, and var4 equals to 400, you say id var3, id var4, id var1, and id var4. Right, so both are in different memory locations, so that's really strange. All right, so never mind. We should always expect this stuff happening in a programming language. It can be a bug, or it can just be something Python doesn't want to do. But like you can see, maybe let's check. Let's say var3 is var4. It gives us false because as you can see, they are not in the same memory location. But it looks like when numbers are too large, Python does not save them in the same memory location. So let's try with smaller numbers, because like we've seen, if we say var1 equals to 2000, and we say var2 equals to 2000, if we check id var1 and id var2, They're not in the same memory location, but it shows Python created duplicates of these values. Let's try it for smaller values. For example, var1 equals to 40, var2 equals to 40. Let's see id var1, comma id var2. Oh yeah, so we see it looks like when the numbers are very small, Python actually saves them. So if you say var1 is var2, we see true. But probably when the numbers are quite big, Python doesn't save them in the same memory location. Let's try for float. Var1 equals to 2.3, var2 equals to 2.3. Let's say id var1, comma id var2. All right, so for float, it doesn't work that way. Python always saves float on its own memory location. It might be a bug currently on my console, or maybe the memory is full, or my memory might be almost full on my computer. So maybe on a different machine or on a different computer, it's going to behave in a different way. But like you see, the is operator only returns true if both var1 and var2, or both operands, you say var1 is var2. This will only return true if var1 and var2 point to the same address in memory. Then is the only time you're going to have true. Now, in the other case, not is not is an opposite to is. So, for example, in this case, if we say is not gives us true because is not is the reverse of is. We say var1 is var2. For example, in this case, var1 equals to 40, var2 equals to 40. Or let's use different numbers. var1 equals to 60, var2 equals to 60, id var1, id var2. All right, so now let's check. var1 is var2. Yeah, it should give us true because, of course, var1 and var2 point to the same object in memory. It means Python did not create two 60s. It actually created the first 60 object with the value 60 and just pointed var2 to that same object. So they actually point to the same object in memory. So if right now var1 is not var2, it should return false because var1 is var2. So var1 is not var2 is a false statement. That's why it returns false. You understand? So while in the other case, if we have var1 equals to 50.5 and we have var2 equals to 50.5, if we say id, let's check the IDs first. var1, comma id var2, let's check. Wow, okay, different memory locations. So if you write var1 is var2, it should return false. But if you write var1 is not var2, it should return true because that's true. var1 is not var2. And take note, this is what you should really take note about. Why it proves is not an equivalent sign. It does not compare the value because actually 50.5 is equal to 50.5. So it shows the is operator does not test the values because if it tested the values, 50.5 of course is equal to 50.5. But for example, if you write 50, if you write var1 is equals to var2, of course it gives you true because 50.5 is equals to 50.5. But if you write var1 is var2, it's giving you false because it's actually testing their memory or the addresses those variables point to rather than their value. It's testing their addresses, and as you can see, this gives us a clear point to understand their addresses are not equal. So the is identity operator only tests the memory address or the address location of variables, not the value. You understand? So that's one, that's the difference between the identity and the comparison operator. Never use the is to compare values. Use the is to compare objects. So that's a good example. At least we are able to see how is the difference between is and equal to, that's it's equal to the comparison operator equal to. So now, like I said, if you write var1 is not var2, it's going to give you true because yes, var1 is not var2. Now, I guess at this point we can say we understand is and not is. Not is just the is not, not is. You understand the difference between is and is not. Is not is the opposite of is, while is just checks the addresses variables point to. It checks the address location of a variable. If the left hand operand address is equal to the right hand operand address, the is operator will return true. Otherwise, the is operator will return false. So like I told you earlier, we're going to try it with classes. Now, classes, we can declare a class in Python, very easy, and I'm going to show you how we can declare a class and create instances of that class. So let's see, for example, when you create a class, let's see. Okay, let's see. Now, let's say we have a class dog. All right, one, two, def, um, and get type, type, self, print, I, and the dog. All right, so the dog class prints itself as a dog. Don't worry if you don't understand classes. We're gonna do classes in a few videos ahead, so you don't need to worry. I just want to explain how the is works with objects of a class. So in this case, we have a class and def and get age self print print I am 20 dog years old. All right, so let's see. All right, so let's see. Now let's create an object of that class. All right, so dog1 equal to dog dog2 equal to dog. Now we can have init, but let's just leave it for the while. Dog. Now let's print dog1 dot get type. I am a dog, none. Then two print it returns none, print dog 2 dot get age, returns I am 20 years old. All right, so we just created two classes, two dogs. So let's see dog one. Let's see ID of dog one, the memory location of dog one, ID dog one. All right, let's see ID dog two. We see there are different memory location. What if you say dog 3 equal to dog 1, and we say dog 3 dot print, now let dog 3 dot get type, dog 3 dot, let's just say get age, I am a dog. So now let's check the memory location of dog 3. Now let's check the memory location of dog 1. As you can clearly see, these two, dog 1, dog 3 and dog 1 point to the same object in memory. As you can see, we created dog 1 from the class dog, We created dog1. Where is it? We created dog1 from the class dog. We created another dog2 from the class dog. Then we now created dog3, but this time we just assigned dog3 to point to dog1. So you see, in this case, dog3 and dog1 point to the same object. That's what you're supposed to, that's what I just wanted you to see. You can use it to check if to an object points is created from another object, or an object points to another object. So once two objects have the same memory address, it means they point to the same object. Once two variables, for example, points to the same object, have the same address, it means they point to the same object. So because these two variables, dog3 and dog1, have the same, here is it, id dog1. In fact, let's do it here. Let's id dog1, comma id dog3. So since the variable dog1 and dog3 point have the same address, it means they point to the same object in memory. So that's just how I wanted you to see how it can be applied to objects as well. Yeah, so it can be applied to objects as well. So like we explained here, let's just do some small reading before we are done. In this case, you see Python wouldn't, like we have var1 here, and var2 equals to 10. Like we've seen from the console, with smaller values, Python doesn't create duplicate numbers. But like we saw in the console, when the values become too large, Python is going to use duplicate addresses. You understand, like we saw with the other examples. So in the case of this small number like 10, Python is good. They are going to point to the same object, because Python will just create one and then point var2 to that, the old one it created. So that's just what I wanted to show you. So in this case, Python will create only one integer object in memory with value 5. It will then set the reference count of the object to 2, since two variables or identifiers, that's var1 and var2, are pointing to the same object. So that object is going to have a reference count of 2. Now, if you say var1 is var2, it will return true, because both var1 and var2 point to the same object. Now, consider another statement where we have 20.5 and var2 equals to 20. In this case, Python will first create a float 20.5, a float object with a value 20.5 and a reference count of 1, because just one variable points to that 20.5. The next line, Python will create an integer object with the value 20, assign it to the variable 2 with the value 20, and assign it to the variable 2, and set its reference count to 1, of course, because only one variable points to it. And in the later on, you're going to see, if you write var1 is var2, it's going to give you false, of course, because they don't point to the same memory location. So like what I wanted to explain to you, Python only shares memory for immutable objects, because it's sure that their value can change after they are created. So like we're seeing here, all numbers are immutable. If you haven't watched a video on mutability, immutability, and the garbage collector, you can check out that video. So we're only working with numbers. It's same like list. If we have a equal to the let's say 1, 2, 3, b equals to 1, 2, 3. Usually, most of the time, if you check IDA, let's just see Python IDB. All right, like you saw with this tuple, Python actually used a different memory location from use different memory locations for them. Let's check another stuff. Let me say a 3.4 3 plus 4j plus 4j b equals to 3 plus 4j. Let's check IDA, IDE. Yeah, I think Python isn't using the same memory location, but I think it's due to my computer. My computer, the RAM is very low, and I think it's almost finished. But usually, normally, when you declare code like this, Python would not create a duplicate memory. You can try that on your PC. If you create a tuple of this form, what Python does is, since it already has an immutable object 1, 2, 3 in memory, and this immutable object can never change, you can never change the value of a tuple. unlike you do with lists. So Python is sure this will never change, so it can just assign B to this same location. It doesn't change it. You understand? Maybe when you're running low on memory, Python does a few things because maybe it discards it once in a while, but normally Python wouldn't do that. Even in this case, Python wouldn't create a duplicate of 3.4J because it already has 3.4J in memory. So yeah, but you need to always test if you want to like make use of that. It's always good to test so you know when Python hasn't done it. That's why the it operator comes in handy. You have to test if you want to do, if your program relies on these packs where you need to check if two values are in the same, two objects or two variables point to the same address, you always need to use the is operator to check, because like you've seen on my computer, Python will not do it most of the time. But for integers, um, floats, complex, booleans, and booleans and tuples. Yes, for those 5 objects, Python will not create duplicate memory objects if it already has. So if you declare a variable with one of those objects and later on in your code you declare another variable with that object, Python is not going to create a duplicate. It's just going to point that new variable to the old object. And if you use the is operator, you will discover that that old object and the ID of the new or of the new variable points has the same address of that old object. So I just want you to know that's possible. So the is operator, you may not use it quite often in your code, but it's just in your programs, but it's just good to know it functions. All right. So that's it for the is operator. We are going to look at the next part. We are going to look at the Python operator precedence, how operators work when they are placed adjacent to each other. So here is just a brief explanation where we check stuffs online, where we check a few stuffs, var1, var2, var3. You see var3 here. So you see we have var3. Um, var1 is var2 gives false, var1 is var3 gives true because they are 340, 340. And var2 is var3 gives false, var3 is not var4 gives true because yes, var3 is not var4, var1 is not var3 gives false because var1 is var4. They point to the same address. var5 is var7 gives false, var5 is not var7 gives true because yes, they don't point to the same address. var6 is var7 gives false because yes, they don't point to the same address. var6 is var9 gives true because they point to the same address. Now var6 is not var8 gives true because as you can see, var6 is not var8. Yes, they don't have the same address. And var8 is not var5 true. var6 is not var9, which is var6, var9, which is false because as you can see, we have var6, we have var9. As you can see, their location is equal. So you can see I did this on a different computer and it works perfectly even for lists, and also for it works perfectly for tuples very well, unlike what I was trying to do here, which did not work. But as you can see from the example, when I did it for tuple on a different computer, it actually works. And I find out the reason is because the RAM of this computer is almost full. As you can see from performance, you can see the RAM memory is almost full. So I believe when the memory of the computer is full, Python uses some other addressing. I mean, the computer is using some other addressing scheme to save variables, maybe using the cache and whatever, pages and whatever. So I believe that's the reason for this unpredictable behavior. All right, so see you in the next video on operator precedence. Have a nice time.